My name is Rémi Jedwab. I'm one of the organizers of the conference. And we're going to have 4 short academic presentations with 18 minutes per paper, and then a discussant will take like 5-7 minutes, and then a Q&A, again 5-7 minutes. Let's start right away to make sure we're on time. So the first paper will be on the effect of a shrinking of Lake Chad in West Africa. It will be presented by my co-author, Román Zárate from the World Bank. And we have 3 co-authors on that paper: Federico Aslop from GW, Carlos Rodriguez Castellan from the World Bank, and Tako Masaki from the World Bank. And Carlos and Taka are also co-organizers of this workshop. And finally, we'll have a discussion by Klaus Desmet. So Román, the floor is yours.
Thank you very much, Rémi. So I'm going to present this paper about the economic effects of the shrinkage of the Lake Chad. And as Rémi said, this paper is with Federico, Taka, Carlos, and Rémi. So in terms of the motivation, let me start with the definition of climate change by the Intergovernmental Panel of Climate Change, which says that climate change can be defined as the change in the state of the climate that can be identified by changes in the mean or in the variability of its properties, but that is going to persist for an extended period of time, typically decades. And in that sense, the literature has taken 2 different approaches to answer what is going to be the effect of climate change. One approach are the empirical studies that have looked at the causal effect of climate shocks, which by constructions are temporary shocks and are not permanent shocks. So there is still a question on how can we measure like the causal effects of these permanent changes. And the second approach is to use like very rich spatial models as the one that Esteban used to simulate what are going to be like the effects of future climate change, but not the climate change that has been happening since 1950. So there is still a question on how can we estimate, not simulated effects of climate change. And in order to do that, we need a shock that it's going to have some properties. For example, the shock needs to be a permanent change in climate-driven geographical condition. The change must be slow enough so that this shock is going to be over several decades. And of course, like in order to estimate causal effects, the shock must be locally exogenous, and we need data like before and after the shock to estimate what is the impact of the shock. In the same way as Esteban did, we can also think in a model that can help us to rationalize some of these effects and to generate clear policy prescriptions. So in this paper, what we are going to study is an unexpected and permanent shrinkage of one of the major lakes in Africa. And we will study what were the effects on the economic outcomes. So just to give you an idea of the shock, this is like a map of the 4 countries that are going to be affected by the shock. So Lake Chad is located at the intersection between 4 different countries: Niger, Chad, Nigeria, and Cameroon. And these 4 countries represent 25% of the population in Sub-Saharan Africa. And in the 1960s, this lake was the 11th largest lake in the world, and it was similar in size to Israel and West Bank Gaza. But what happened is that there was a decrease in the rainfall in Central African Republic that basically started to decrease the size of the lake. So here are like some satellite images of the lake. So this is like the lake in 1960s. And as you can observe, as we evolve over time, the lake started to shrink. And I will explain later why the shock was locally exogenous. So the research question that we study in this paper is what were like the effects of this shrinking of the Lake Chad. We think that the effects are a priori ambiguous. Of course, there is going to be less water, but people are also getting to get more land, so they can start like working more in the agricultural sector. And at the same time, because this is a shock to the primary sector, people can move to cities, which can increase economic activity. So we think that the effects are priori ambiguous. So what we're going to do in this paper is that we're going to collect like very good data for population estimates in Cameroon, Chad, and Niger and Nigeria, and the evolution over time. And we will calculate what was the effect on population of the shrinkage of the lake. We're going to find much lower population growth around the areas that got affected by the shock, but we're not going to find effects on city population, which means that there can be some refugee urbanization because of the shock. Then we're going to build a super simple spatial model. It is just a static model in which there are going to be multiple locations, but it's going to have some of the elements from Esteban's paper. So there is going to be trade, there is going to be migration, and we're going to use this model to quantify like the aggregate effects of the shock. And we're going to find that the shock is going to decrease real income by 2% in these countries. And we're also going to use the model to try to study the effect of some of these policies. So just to give you an idea of how the lake was evolving over time, as you can observe here, so in the y-axis, I have like the total surface of the area of the lake, and in the x-axis, I have like the timeline. And as you can observe, like starting in 1965, there was a shrinkage of the lake, and in 1990, the lakes lost like 90% of its size. So why we think that this shock is locally exogenous? So Lake Chad is a sink that is fed by rain, and the rain usually needs to be generated in Central African Republic. So almost of the lake's water is going to come from the Logon-Chari River complex, which are these stems that I'm showing here. And because the rainfall decrease in Central African Republic, we think that the shock was not correlated with the economic conditions in the areas close to the lake. So the rain decreased here. Of course, less water is going to move from Central African Republic to the lake, and the lake started to shrink. And we think that Niger is going to be a more exogenous shock because, as I'm showing in the map, Niger doesn't have this Logon-Chari River complex, so it is not going to be directly affected by the shock. And in order to control for the shock in other countries as well, we're also going to include like the distance to the axis of this river system. So we think that there are many possible mechanisms that make this shock or the effects of these shocks a priori ambiguous. You are going to have, of course, a direct shock in the fishing sector. In the farming sector, there is going to be more land, but at the same time, productivity can be decreasing because of temperature, because of rainfall shocks, and you can have all these mechanisms in the model that make that the effect is ambiguous. So this is just an image of the different locations that are close to the lake and how they have evolved over time. There are many things that can be going on here. Of course, that land is going to become more available, but at the same time, like in these areas, there is lack of property right, there is lack of infrastructure, which make that some of the effects of the shocks are going to be a priori ambiguous. Now, in terms of the data, we're going to use like data from census and post-colonial and administrative counts, in which we are going to be able to calculate population data at the sub-district level for several decades. Like, of course, the data is going to vary across countries. Like in the case of Nigeria, there are some quality issues with the census. So we think that Niger is the best country in which we can do the analysis, but we're going to do the analysis for the 4 countries as well. And we're also going to use city population data in which we collect information of the populations in cities that at some point were beyond 5,000 people. So this is just like the same figure that I showed you at the beginning. So what we're going to do is that we're going to calculate the distance of each one of these sub-districts to the lake, and we're going to run a standard difference in difference specification, including like many controls. So we run this standard difference in difference in which we're going to estimate like different coefficients in which we're going to interact the proximity to the lake, which is the log Euclidean distance with time domain variables. And we're going to include like a bunch of fixed effects. We're going to include like area fixed effects, time fixed effects. And in order to control for some of the initial condition of these subdistricts, we're going to interact some of the initial characteristics with time dummies. So for example, we're going to include like the distance to the capital and most populated city. We're going to include a dummy if it is like if the subdistrict is crossed by the Logon-Chari River system, which is capturing like the RX shock. And we're also going to include like latitude as a control. So there are going to be specific trends that are going to vary with the characteristics. So what are we going to find? So these are the results for Niger, which we think that is the country with the most exogenous shock and also with very high quality data. So what we're going to find, for example, here is that before 1965, which is before the shock, there are some parallel trends. So it doesn't seem that these locations, like the population was growing more or less in this location. But after 1965, there is going to be a decrease in the population that is close to LA. And the standard errors are kind of large, but the point estimates are big. So this means that there is an elasticity of distance to LA with respect to population of minus 0.4, which is big. And actually, we find like similar effects in other countries. So this is like a graph that summarizes like the effects in all the countries. So what we are finding is an average elasticity across the countries of minus 0.6, which means that population in this area decreased by 45 to 50%. And when we exclude Nigeria, which is the country that may have some quality issues in terms of the data, the elasticity decreases to minus 0.4, but still like the effects on population are large, are between 30 to 35%. So we also analyze what is the effect of the shock on cities to see what is driving like the change in the population, if it is rural population or if it is urban population. And we use like the log of the population in cities or a dummy variable if the city is larger than 5,000 people in year T. And the idea here is to see what's going on with urbanization, and in particular, if population grows relatively lower, like in the area that got affected by the shock, it means that urbanization rates are increasing in these areas, and that can help to mitigate some of the negative effects of the shock. And what we actually find is that in terms of population, there is not a clear pattern across countries. For example, for Niger, we actually find that population increases. For Chad, we find that decreases. But in general, we think that there is not a widespread decline in city population, which means that urbanization rates are actually increasing in some of the areas that got affected by the shock. And in order to calibrate like this spatial model, we also analyze what is the effect on climate change in terms of rainfall and temperature. And the idea here is that the lake has two effects. The first effect is that as water evaporates, you have the cycle of water, so that is going to generate more rain in these locations. And similarly, as the size of the lake is bigger, there is like a cooler effect, so a cooling effect, so that is going to decrease temperature. So we run like the same difference in difference, but instead of using like population as an outcome, we use like the log mean of the annual rainfall and the monthly temperature. And what we find is that in this location, there is going to be some rainfall losses between 0 and 30%. And similarly, like temperature is going to increase in some of these locations between 0 to 3%. So when we're going to include these effects like in the spatial model, but such that productivity is going to be affected by these rainfall losses and also by these temperature increases. So then we develop a very simple quantitative spatial model. It is like the simplest model that you can think about it. So the economy is going to be closed in these 4 countries. There are going to be multiple locations. We're going to use like the subdistrict, which is the unit of analysis in the reduced form. There are going to be like trade frictions in the model. So we are going to have like iceberg trade costs in the model. And in terms of the production, there are going to be multiple sectors, in particular 4 sectors. There is going to be a fishing sector, a livestock sector, an agricultural sector, and an urban sector. And there is going to be perfect competition and 1 representative per sector and location. And we're going to assume that the production function is Cobb-Douglas. So there are going to be 3 inputs in the production function. 1 is going to be labor, the other 1 is going to be water, and a 3rd factor of production that is land. And based on recent study, we're going to assume that there are some agglomeration forces, but that these agglomeration forces are only present in the urban sector.
Yeah, you have 5 minutes. Huh?
Yes, sounds good, Rémi. Thank you. In terms of the preferences, we're going to assume a nested structure. In the upper nest, the preferences are going to be Cobb-Douglas. In the lower nest, we're going to have a classic Armington model with CS. And we're going to analyze like different migration channels. So we're going to analyze a counterfactual in which there is free migration, so that people can migrate across countries, one in which only people can only migrate within countries, within ethnic groups, and when their migration frictions are so large that there is no migration at all. In terms of the calibration of the model, we're going to use data from FAO, and we're going to use expenditure share tables from the 1960s. And for the elasticities, we're going to take them directly from previous studies. So just to let you know what is the shock that we do into the model, the main counterfactual, basically we're shocking like the fishing sector by decreasing like the water supply in the fishing sector exactly by matching the satellite images from the lake. And we're also going to have a farming shock and a livestock shock because of this temperature increase or this rainfall decrease. So these are like the results in terms of population. So what we observe here is that, of course, like there is going to be a decrease in the population close to the areas of the lake. In the case in which there is only migration within countries, people are going to move to the east of Chad because Chad is the country that is going to be more affected by the shock. While in the case in which there is free migration, people are going to move to the coast in Nigeria and Cameroon. So people are moving to these areas that specialize like in the production of fishing. In terms of welfare, like what we observe here is that the change in welfare, of course, is going like there is going to be a large decrease in welfare in the locations that are close to the lake. That the locations that are going to specialize more in the fishing sector are going to gain. So we actually observe that there is some positive gains in the coast of Nigeria and Cameroon, and that this location that is close to the lake but still is going to have access to the lake, it's also going to experience some of the gains because that location specializes in the production of fishing, and people have also preferences for the fishing sector. Now, in terms of welfare, what we observe here is that in the case in which there is only migration within countries, like the welfare losses are going to be larger for Chad because people are going to move less to Chad in the case in which there is free migration, and because you have these congestion forces, that is going to increase the welfare losses. Now, in terms of the aggregate effect, so we run like the simulations for different value of the agglomeration force and the congestion force. But in general, when we analyze migration within countries, there is an aggregate economic loss in welfare of 2%. When we compare with the case in which there is no migration, of course, migration is going to increase these welfare losses, and the welfare losses are going to increase by 5.5%. Which means that migration is an important channel to mitigate some of the negative effects of climate change. Now, something that it's kind of weird for us is that when we compare like the counterfactual in which there is only migration within countries versus a counterfactual in which there is migration across all locations, we find larger welfare losses in the counterfactual in which there is migration across all locations. So the losses here are going to be 2.5% of real income. And one explanation that we have for the channel is because of urbanization. So when there is only migration within countries, like people are going to move more to the urban sector because this urban sector has these agglomeration forces that is going to help to mitigate some of these losses. When there is only migration across countries, people are going to move to other countries, but they are going to still work in the agricultural sector, in the primary sector, and that is not going to mitigate by that much the losses. We also try to match like the elasticities that we found in the reduced form. We think that the model is doing a good job. We are like finding an elasticity of minus 0.23. In the reduced form, we're finding an elasticity of minus 0.4, but the model is still not accounting for some of the channels. So we're not accounting for the change in mortality rate or the change in conflict. So we think that we need to incorporate the channels into the model or to try to disentangle those mechanisms in the reduced form. But so far, the model is doing a good job matching this elasticity. And finally, we run like some counterfactuals, like in terms of optimal policy. So what would have happened if the government tried to mitigate some of the effects by building roads? And we estimate the effects of 3 different counterfactuals if they build roads close to the lake, connecting the lake to the largest cities or closest to the lake. And what we have find is that if the government actually connects some of these areas to the lake or to the largest cities, the welfare losses are going to be smaller. And again, like this can mitigate some of the effects, especially benefiting the areas that are close to the lake versus the other areas in these four countries. So let me conclude. What this paper has shown is that the disappearance of Lake Chad had some effects on the economic outcomes, especially on population. And then we built this quantitative spatial model finding that on average, there were aggregate welfare losses of 2%, and that migration and roads may matter to mitigate some of these effects. So thank you.
Great, thank you so much. In interest of time, now we have Klaus Desmet, who's going to discuss a paper in Klaus is from SMU. So Klaus, the floor is yours.
Let me stop sharing. Okay, thank you.
Okay, good morning, everybody, and thank you so much for giving me the opportunity to discuss this work by Román, Rémi, and co-authors. It's a very new paper. I actually received it just a few days ago, and so hopefully some of these comments may be useful. Okay, so without further ado, as you've seen, this paper looks at the spatial economic effects of the disappearance of Lake Chad. As Román said, this is not just any lake. It used to be the 11th largest lake in the world, about the size of Massachusetts, and it borders 4 countries. There's 2 aspects of this paper that I find particularly attractive in this context. One is that it focuses on persistent climate change, which is of course different from weather shocks. You know, Richard in his discussion, in his first discussion, also made this point. You know, weather and climate are not the same things, and I have the impression that sometimes the work on Sub-Saharan Africa confuses weather shocks from climate change. So I think this is a very appropriate context to look at these more drawn out changes over longer periods of time that are likely to be persistent. So that's one aspect I really think is useful about the paper that we just saw presented today. And the second one is that it is actually focusing on a very interesting historical episode. A lot of the work on climate change, needless to say, focuses on future projections, because of course most of the problems are yet to come, and we need models to see you know, what might happen in the future. But in this case, we're looking at something that has happened in the past, and I think that's useful, partly as well because it provides us for more ways, I think, to test how reasonable the model is. We can think about what is the more appropriate structure of the model to study climate change, precisely because, you know, we're actually looking at an episode for which we in principle have good data. So that's where I kind of see the contribution of this work in a broader context. So I'm going to be very brief. I'm going to make a few comments on the data and empirical part, and then a few comments on the theory. On the data, I would actually have enjoyed a little bit more background on what exactly are the different economic uses of this lake. Is the lake important for drinking water? Is the lake a very important source for the fishing industry? Is the lake mainly used for transportation? So just trying to get, for the reader, getting a bit more of an idea of what exactly this lake used to do, I think is important. In terms of the empirical specification, you look at how population changes as a function to distance to the lake. But then what I was thinking is that, the distance to the lake, of course, changes over time as this lake dries out. And so being close to the lake may be bad in some areas simply because I'm close to the lake and the lake is drying out, but the lake is not drying out everywhere. And so proximity to the lake in some areas may actually be a gain. In other areas, it may be a loss, depending whether the lake is actually drying out or not, because of course the lake didn't dry out completely. A second point is that maybe thinking a bit more about the heterogeneity of the effects of drying out, how that may interact with certain characteristics of locations, the land quality, for example, and other features. On the effect on urbanization, I thought that was very interesting. The fact that people move to cities. We know from the work of Henderson and Storygard on Sub-Saharan Africa that move to cities may actually depend on the type of city. Are there jobs available there? Is it a manufacturing city? So trying to understand that part a little bit better, I think would be useful as well. And then lastly, if at all, and this is of course very much a conditional statement, I think it would be super interesting if you were to be able to get maybe at least for some of these countries sectoral data on employment at a relatively high spatial resolution. I think that would add an additional very interesting dimension to the paper. On the model, and this will be my last slide here, what I like is this approach that Román and Rémi took of saying, okay, this lake is drying out. What kind of shock is this? It's a shock to water transportation. It's a shock to the water supply, and water is important, say, for fisheries. It's also a productivity change, maybe a positive productivity change for agriculture and livestock, because the loss of water is a gain in land. So thinking of the drying out of the lake as a combination of different shocks, I thought that was very useful as a way of trying to run the different effects of the drying out through the structure of the model. I think more work is needed, and from reading the paper, you're planning to do more work on comparing predicted changes by the model to actual changes. And again, it would be wonderful if you could go beyond looking at, population changes by location, and if you could also do maybe something about sector composition changes. The reason why I'm saying this is because, of course, you make a lot in both the sort of in your introduction and in the model, you talk a lot about fisheries, agriculture, livestock, all these different sectors, but then you don't really have data on all these different sectors at a local level. And I think that'd be really nice if you could do this. A third point is going back to these different shocks, right? Water transportation, water supply, etc. Going even a little bit further and trying to quantify the relative importance of these different channels. Sort of saying, okay, so the welfare effect is such and such. If the lake were only to be used for water transportation, what would it have been? If the lake were only to be used for fishery, what would the effect have been? Just to get a sense of what is this loss of the lake, through which main channel is it actually operating? And then lastly, is of course a bit of an obvious point here, but nonetheless maybe important, is at the moment you're modeling migration costs as sort of either being free or prohibitive. Of course, in reality, it's often somewhere in between. And so given how important migration is in your model, anything you can do to make that part more realistic, I think would also be very useful. So anyway, wrapping up, I think this was a very nice paper, and again, a wonderful application. I think it's important to think about some of these historical episodes, because they can also help us it can help us guide our thinking about the types of ingredients we want to build into climate models that can help us make future projections. So thank you very much.
Great, because this was perfect. I think again, in the interest of time, maybe what we can do is, I see there's a question from the chat. I think all the points are very well taken, and that's great. We can talk more. The question in the chat from Oscar is that what was the impact of shrinkage of the lake on the local climate, and how did this affect the miles estimation? So, if Román, you can talk about how the lake may have impacted rainfall and temperature as well.
Yeah, so that was like table 4 that I showed in the presentation. So what we basically did was to look at what happened to rainfall and what happened to temperature using like the same difference in different specification. And what we found is that there is an effect of the shrinkage of the lake in rainfall and also in temperature. So there is some effect because of the water cycle. So as I mentioned, like in the presentation, like usually water evaporates and that creates rain. As the size of the lake decreases, there's going to be less water evaporation, and similarly, like the lake has this cooling effect on temperature. So we found both effects when we ran the difference in difference.
And then we try to add the impact of these changes on yields, on extinction as well of cattle breeds. When you have like less rainfall, higher temperatures, this will have an impact on cattle productivity, not just like farming productivity. But are there more questions, for example, from a panel? Like you can, for example, unmute yourself if you want to ask a question. Yeah, Esteban, go ahead.
Yeah, so thanks for the paper. It looks great. I think one part that at least wasn't that clear to me is so I think it's great to use this type of events to try to fine-tune these models, but it would be great to be very clear about exactly what is exactly the mechanism that is being quote unquote tested when you use this type of real life event. So it's great to understand what's happened, but in some sense, as far as I understand, you can build these models and essentially kind of back out what are the migration costs, what are the elasticities that are going to rationalize what you saw as an outcome. And so as an estimation strategy for those migration costs and those elasticities, of course, this can be great, right? But that's, of course, not testing the model itself. So if we want to test the model itself, we have to kind of go one step further and say, well, conditional on what those migration costs are, conditional on those elasticities, can the model reproduce something else that we see, etc. And so, if you want to exploit this event and use this to try to think about model development in that sense, I think you need to be kind of a little bit clearer on that. And why is it not, or maybe that's not the point. I mean, the point is just to estimate in these regions of Africa, what are the migration costs and what are the relevant elasticities? And I think that's also very valuable. But then, of course, it's not about model testing or model construction.
Yeah, so that's an excellent point, Stan. So far, what we have been doing with the model is that we are using the model to calculate what were the aggregate effects, and you are totally right that the thing that we're doing now is just backing out the elasticities, backing out the migration cost. Now, to test like how good is the fit of the model, of course, we will need some other source of data, and that's something that we need to work out. It's like it is very difficult to get data in this context, but I totally get your point that like right now this is not testing the model. Right now, what we're doing is just using the model to calculate like what are the aggregate welfare losses. And in order to test the model, we need to target moments that we're not going to use in the estimation or in the calibration of the migration cost. And we're working to get data on that aspect and see if we can test the model in a better way than what we are doing right now. But I totally get your point. So thank you very much for that comment.